properties, this is what your quiz is going to be on tomorrow, Wednesday. So exponents, the base indicates the number of times that the base is being multiplied by itself. So x to the n, that first property tells us that we have n factors of x. X is the base value, n is our exponent. Exponents represent mathematical shorthand for multiplication. Numbers expressed using exponents are called powers. So if you leave it as x to the n, that is considered a power. Older calculators, computers often use that operator, that up key or the caret key to represent our exponents. A lot of ours have x to the second on them, and then you'll see that y to the x is also used. Okay, it says beware. This -4 to the second and -4 or -4 to the second power without a parenthesis are not the same. Keeping in mind, this is going to give us positive 16. Whereas when you have that -4 to the second and there is not a parenthesis, it really means almost this, -1 times that 4 to the second. So negative, and then you're squaring the 4. So that gives us a -16 versus a positive 16. Okay? So those are kind of some common mistakes that people make. It says, thinking of the negative sign as -1 or the opposite of 4 squared. So -4 in parentheses is read as -4, that quantity squared. This one is read as negative of 4 squared. So the opposite of 4 squared. That's what you're thinking. Okay? So you kind of got to be aware of that as you are looking at it. So then the properties. And instead of me writing them, because my handwriting is okay but not great, when you have to write all of these. So the zero exponent. X to the 0 equals 1. In plain English, what are we looking at? All numbers raised to the 0 power equal 1. Not 0, equal 1. So if you're filling that table in, okay? Negative exponents. Negative exponents say x to the -m. And here is where on the quiz, what some of you were telling me, you said that it always moves to the denominator to make it positive. Well, not necessarily, because what if you have this problem as 1 over x to the -m? What it's really doing is always telling you to take the reciprocal. So that keyword reciprocal is what we are looking at. That's what I was kind of looking for when we did that explanation that day on your quiz, that homework quiz, was explaining it, and that really means reciprocal. If we are looking at that next one, the product rule. So product, this is kind of where I introduced, after we did the product and the powers, where I started talking about that name of trying to remember. But when you are multiplying the same base, and it has to be the same base, right? When we multiply that same base, we are adding our exponents. So what we just learned yesterday was that quotient rule, which is when you divide with the same base, you're subtracting. Always thinking of our top exponent subtracting. And where I saw a lot of mistakes on people's work, I had a couple people in this morning, we were looking at their stuff. Subtracting a negative is the same, or just minusing that negative number, that does become plus a positive. So remembering your rules of integers. Power to a power and product to a power. Okay? Power to a power, that just means you have x to the m raised to the n. And then when you have two things inside that, all it means is each thing has to be raised to that power, and you are still multiplying. So this is when I was talking about, so we add when we multiply, we subtract when we're dividing, we multiply those, and raising each factor to the power. Okay? This is where I was talking about that name for a mnemonic to help you remember, in that when you have exponents raised to an exponent, so here, x to the m raised to the n, what should you be doing with those two? You should multiply them. When you are multiplying two powers, what do you do to the exponents? You add the exponent. Okay, so if you're thinking of that, we add that exponent. And if you are adding exponents, meaning like 2x to the second plus 3x to the second, what are you doing to the exponent? You are doing nothing to the exponent. In that this answer would be equal to 5 and x to the second. This stays the same. You do nothing to the exponent. Whereas here it's always telling you what to do to the exponent. Power to a power, you multiply. Multiplying with the same base, you add. And when you add, you should do nothing. Okay, so kind of keeping that in mind for a mnemonic to help you remember. The quotient to a power, that's just our last one. It's very similar to the product to a power and the power to a power. It's just saying that when you have that fraction to the exponent, and again, you're always going to notice that they usually tell us something can't equal 0 with those fractions because division by 0 is impossible or it gives us undefined. Raising a quotient to a power, you got to just make sure you're doing both to that power. Okay? So tomorrow's quiz is 15 questions, 2 points each. You will see negative exponents. You'll see some easy ones, like something to the 0 power. And I will have people tell me the answer is 0 instead of 1, which is wrong. I will have people leave negative exponents on the quiz. Any negative exponents will definitely be marked wrong. I don't care if it's in the numerator or the denominator. Simplified means that you are not going to see the same base in either the numerator or denominator or going in that same problem. I can't see these x's, x to the 4th and x to the 5th. That's not simplified. Just like on that quiz when I multiply or mark some of yours wrong when you had negative 5 times 8. Negative 5 times 8, you don't want to leave it as negative 5 times 8. You want to tell me it's negative 40. So you want to multiply everything, divide the fractions out. So just like in class when we were talking about what if you have 10 divided by 5, you want to write that as 2. You don't want to leave it as 10 over 5 because that can be simplified. So you're simplifying not only your coefficients, but you're simplifying your whole problem. Okay? So these are the rules that you have. There really aren't any other notes. And I know that as you are working on your assignment, answers are in the back as you are working on this F4. I want to take a look at the scientific notation ones. Let's go to number 20. Number 20. So, same rules apply for dividing as they did with our exponent rules. So, what you are going to do on your calculator is take 3.6 and you're going to divide it by 1.5. You don't have a calculator right now. Take that out. If you do, take it out. If not, I have some up in front. So we're taking our 3.6 and we're dividing it, because that is a division line, dividing it by 1.5. What do we end up with? 2.4. So we are looking at this equals 2.4 times 10. And what are we doing with our exponents when we divide? We're subtracting. So 7 minus 2, 3. So 7 minus 3 is going to give us 10 to the 4th. This answer in scientific notation is saying it is. I do not believe there are no problems with scientific notation on the quiz tomorrow. There might be on this test, but there's not on the quiz. Okay? So don't get too stressed out about those as you're working with those. And then this last one, they're asking you what was the mistake, what is the correct simplification, the division property, make sure what's the shortcut, explain why it doesn't work when you have different bases. Okay? So if you have x's and y's. And then this says this is the area of the triangle and the height is this. So if you think of that area of a triangle formula, what is area of a triangle?
Base times height times a half.
Base times height times a half. So if you were going to fill in number 25, what would you put for area? What did they tell us? 80. x to the 5th and y to the 2nd. I don't care if you go with 1/2 or 0.5. And we don't know the base, right? What's that? Oh, y to the 5th. So 1/2, we don't know our base, so that's what we're going to be solving for, but we know our height. And our height in this case was x to the 4th and y. Now, my hint might be, I would maybe solve this equation. It's a literal equation. We did it at the beginning of the year. I'd solve this equation for h first. I would rewrite this equation and get it in forms of h first, and then plug in what you have. B. Good thing you're with me today. Okay, so solve it for b first. That would be my hint, but you don't have to. You can do it from here. It's just that it gets a little more ugly. My hint would be get it at b equals and have that one big fraction here. So here you multiply both sides by 2 and divided by, right? I would do that first as well.